Hello everyone, my name is Apurva Kapil. I'm working as an assistant professor at the Department of Computer Engineering in Silver Oak University. The outline which will be covered in today's videos are stated as Introduction to AI, Classification of AI, Applications of AI, Types of Problem in AI, Types of Learning, Process of AI, and Essence of Data Preprocessing. Talking about what is AI. AI is a broader concept mimicking human intelligence. ML is a subset of AI that learns patterns from data, and DL is a subset of machine learning using neural network for complex tasks. We cannot also say when we try to incorporate human brain or human intelligence in a machine is known as artificial intelligence. Talking about machine learning, we are already aware that machine learning is a subset of AI and deep learning is a subset of machine learning. Now, we have classified AI into three categories. The first is weak AI, then we have strong AI, and then we have evolutionary AI. Let's try to understand what is weak AI. Weak AI, the study and design of machines that perform intelligent tasks, is known as a weak AI. For example, there is a flying machine which is an example of weak AI. We have strong AI, the study and design of machines that stimulates the human mind to perform intelligent tasks that borrows many ideas from psychology or neuroscience is known as in strong AI. The study and design of machines that stimulate simple creatures and attempt to involve and have higher level emergent behavior is known as an evolutionary AI. Now, as AI is evolving, we are using it in our day-to-day life. There are many applications of AI which we are using in our day-to-day lives. Few applications of AI are gaming, speech recognition, handwriting recognition, intelligent robots, AI in healthcare, and many more. Let's try to understand how AI in healthcare is used. Let's assume a person is detected with cancer. Now, how does AI help to detect the cancers? The machine which we are using to detect it, it may be a CT scan, it may be an MRI machine, or it may be a medical machine which is used to detect cancer, is made of AI. We can also use AI to enhance those medical images. In few cases, we have already seen that if we try to look into the MRI is sometimes not clearly visible. So, by using GANs, which is a type of AI used in deep learning concepts, we can enhance those particular regions in which we want to clearly see the cells or the nerve from which the particular disease has started evolving or started producing its cells in the body. AI is also used for speech recognition, which means if there is a study which states that majorly suppose the speech which I am giving right now is being translated in some or the other form which is easily audible to you guys, but it can be possible that if we talk about Gujarati language, which is still not being able to recognize because of the emotions people have, each person differs in their vocal voice, they differ in their tone, they also differ in the spelling. Speech plays a major role. So AI is vastly used everywhere. Now, if we are using AI, but obvious we will have some problems which we are going to face in that. So there are three types of problems in AI. The first is ignorable, we have recoverable, and the third one is irrecoverable. If I talk about ignorable, the solutions or the steps which can be ignored is known as ignorable problem. Let's assume, suppose we are calculating a sum, and in that sum, if the mistake is of 0, we can eventually ignore that. So that is known as an ignorable problem. If I talk about recoverable problem, the solutions or the steps can be undone. By undone, what I mean is, if we are playing a game of chess and in that chess I have kept my horse in the wrong position, I can undo it and keep it at the correct position. That is known as recoverable problem. And if I talk about irrecoverable problem, we can say that the solutions and the steps cannot be undone. By undone, I mean you have already circulated a solution and now you cannot change the solution. So that is known as an irrecoverable problem. Now, talking about machine learning, we have already studied that what is machine learning. Machine learning is basically a subset of AI. There are 4 types of learning in machine learning. First is supervised learning, we have unsupervised learning, we have semi-supervised learning, and then we have reinforcement learning. Now, what is supervised learning? Supervised learning is a category of machine learning that uses labeled data sets to train algorithms to predict outcomes and recognize patterns. What does it mean there? As in the PPT, you can see we have 2 sets of data, which is the labeled data, and what we are doing is we are training that data to predict which sort of category of fruits or vegetables we have. We can also take an example as in the classroom, when the mentor is present, the class is completely silent. But as and when the mentor steps out of the classroom, there is a noise. So which means if a mentor is present, then and then we can train the data, and if the mentor is not there, then we cannot train the data. Talking about unsupervised learning. Unsupervised learning is a type of machine learning that learns from data without human supervision. For an example, here you can see we have kept a raw data. An algorithm is applied to that raw data, and then we have scattered images of apples, strawberries, and mangoes, which means the unsupervised learning does not need any human supervision to run that data. Now, talking about semi-supervised learning. Semi-supervised learning is a combination of supervised and unsupervised learning. It uses a small amount of labeled data and a large amount of unlabeled data, which provides the benefits of both unsupervised and supervised learning while avoiding the challenges to find a large amount of labeled data. Now, what does semi-supervised learning does? It can use both sort of data, which is the labeled data and the unlabeled data, which is it is a combination of supervised and unsupervised learning. What will it do is, if we have an input in which we have mixed fruits, it will use a machine learning algorithm and then predict whether the fruit is an apple, whether the fruit is a banana, or whether the fruit is an orange. Keeping in mind, there are challenges in both supervised and unsupervised learning. So to avoid the challenges of finding a large amount of labeled data, we can use semi-supervised learning. It's not necessary that we will always get a labeled data. So the advantage of using semi-supervised learning is it works on both sort of data, which is labeled and unlabeled data. The third we have is reinforcement learning. Reinforcement learning is a machine learning approach where an agent learns to make sequential decisions through trial and error. By trial and error, I mean is we will try to run a particular algorithms x many of times until and unless we are getting a desired input. As you might be aware, we play a game x and 0. In that, what we are doing is we particularly continue to play the game until and unless one is the winner. So that is sort of a reinforcement learning. Let's understand the journey of turning data into intelligent decision. The process of AI includes data collection, data pre-processing, feature extraction, model training, model evaluation, deployment and inference, continuous monitoring and improvement. Let's try to break and understand the process. What is data collection? The AI process begins with gathering data from different sources. This can include information like numbers, text, images, or videos. Basically, collecting data from XYZ websites, which can be in the form of numbers, text, images, or video, is known as data collection. Data pre-processing. Once we have the data, we need to clean and organize it. This step involves removing any errors, duplicates, or irrelevant part, which means if we have taken an image or downloaded an image, we need to clean that image first. It might be possible there won't be any sort of label on the image, so we are going to label the image. Then we need to look into it if there are any errors. If the image size is bigger, we need to slice the image so that it can we can easily input that image in our model. So data pre-processing has many steps like labeling the data, slicing the image, removing errors or duplicates if there is any. The next is feature extraction. Now we need to extract the most important parts of the data. These are called features and they help the AI algorithm understand what significance is in the data. Feature extraction means if there is an image of a dog, let's understand it with an example. If there is an image of a dog, so what we did is we collected the image from the website or Google. Second thing, we did a pre-processing step. We cleaned the image, we labeled the image, we tried to, if there were any errors, we tried to remove the errors, and now we are trying to extract its feature. Now what features will be considered as feature extraction of that particular image? The eyes of the dog, nose, ears, hands are considered as features of that particular image. So these three steps are the phase 1 of image processing. Now the second is model training, the phase 2. Model training, next we need to extract features into AI models. These models are like intelligent algorithms that learn from the data. Model evaluation. Once the model has been trained, we need to check out how well it performs. We use evaluation metrics to measure its accuracy or effectiveness. This step helps us to ensure that the model is reliable and provides valuable insights. It's like testing the model to make sure it's doing a good job. Deployment and inference. After training and evaluation, we put the model to work in the real world. We integrate it into systems or applications where it can process new unseen data and provide predictions or decision. Which means if talking about model training, now what we will do is the features which we have extracted in the third step, which is feature extraction, we are going to take those features and will train an algorithm based on that features, which can also state that we are training our feature extracted data on a particular algorithm. We can use X number of algorithms for the same data. Model evaluation means if we have now, once we run our model, we have trained it, now we are evaluating it on the basis of matrix, which can be accuracy, precision, recall, F, anything. Now when we use this particular model to evaluate our data, we get an accurate answer which helps us to deploy the particular application which we are going to run. Now the last step we have is continuous monitoring and improvement. As we are aware, AI is an ongoing process. We regularly monitor the model's performance, collect feedback and update it as needed. By understanding the AI process, we can appreciate how data is transformed into intelligent decisions. From collecting and pre-processing data to training models and deploying them, each step plays a vital role in making AI systems effective and reliable. Suppose nowadays we have updates in our applications. What's the cause of that? That is simply AI. Each and everything, as and when the demand changes, the applications get updated, and it's an ongoing process. We cannot stop it. We collect the feedback. There's a company which has designed a particular app. What the company will do is, once the particular app is launched in the App Store or in the Play Store, they will start collecting the reviews from their customer, which will help them to improve more, and there will be a chance for getting an idea which can be incorporated in that particular application. Now, what are the essence of data pre-processing? Before that, let's understand why does data pre-processing matters. Data pre-processing lays the groundwork for machine learning models by refining messy, incomplete real-world data into a polished form conducive to accurate analysis. Understanding the essence of data pre-processing in machine learning is a key. It's the art of refining raw data into a format interpretable by machine learning algorithms. From text to visuals, real-world data arrives unorganized, inconsistent and often incomplete from the structured form machines prefer. That's where data pre-processing helps in harmonizing this separate data into a uniform and analyzable framework. Let's explore the pivotal task within data pre-processing, which is data cleaning, data integration, data transform, and data reduction. Now, why data pre-processing matters? Like, what's the need of data pre-processing? If we are not pre-processing the data, it might be possible that once we incorporate any algorithm in that, it won't be able to produce a fantastic result. Hence, in case to get a very good accuracy, a very good precision, a very good recall value, we need the image to be polished, to be clear and to be easily understandable by our algorithm or our systems. That's the reason data pre-processing plays an important role for the same. Data preprocessing is nothing but redefining the raw data which might be incomplete, which might be messy, and then we convert it into a polished form which is more understandable, more easy to learn, and more accurate to incorporate in our day-to-day algorithms or in any algorithm we are going to use. Let's try to understand each and every process. Now, talking about data cleaning. Detecting and rectifying errors, duplicates, and missing value essential for the data set. What does it means is, if we are taking an image, we need to look into the image. There should not be any errors, there should not be any duplicate values, and there should not be any missing values required for our model to get trained on the particular data set. We have data integration. Data integration means merging information from diverse sources into an unified data set, navigating varied form and semantics. Like what we are doing is we are merging, if we have collected a data from 3 to 4 websites, what we are going to do is we are going to merge all those data into one particular image or one particular text. That is known as data integration. And the third we have is data transformation. Formatting data for analysis through techniques like normalization and standardization is known as data transformation, which is if we have taken a data, somewhere it is required to transform the data. Like it's not necessary each and every model will run through the same sort of data. So what we'll do it, we will transfer the data into any normal normal form using the normalization and standardization technique. The third we have is data reduction. Reducing data sets while retraining crucial information via feature selection and extraction is known as data reduction, which means if we have taken a data, now to process the data we need to reduce. It might be possible that the size of image is a big long. So to reduce and to extract the useful information, we can use the data reduction technique to minimize the data and to extract the useful features which would play a vital role in incorporating into our model. That's all for today. Thank you.